Welcome to module number 10, and this module talks about implementing monitoring elasticity and high availability. It's a knowledge check, and we'll go through all the right answers and the justification for right and wrong answers. So let's go and start our question number one. Question number one says that which statement about Amazon EC2 auto scaling is correct? And the only right answer in this one is that it can launch Amazon EC2 instance in multiple availability zones. When you set up auto scaling group, you can choose multiple availability zones within a region. Auto scaling will automatically distribute EC2 instances across those zones, ensuring your application remains highly available even if one zone experiences an outage. This helps balance load and improve fault tolerance without manual effort. So let's go through the other options, that why they are not the right options. It can launch new Amazon EC2 instances based on the schedule. That's wrong, because while auto scaling can do schedule scaling, that's just one specific feature. The question asked for the general accurate statement about auto scaling and distributing instances across multiple availability zones, which defines its core functionality for high availability. So the second option, which was over here, was it can launch Amazon EC2 instances, but customers must terminate instances after they are no longer needed. Now, this is also not the right answer, because auto scaling automatically handles both launching and terminating instances. You don't need to manually shut down the instances. It maintains the desired capacity on its own. Then the third option, that it requires the customer to use reserved instances only. This is also wrong, because auto scaling works with on-demand spot and reserved instances. It's not restricted to any one type of pricing model. Question number two says that a DevOps engineer detected that the demand of the fleet of Amazon EC2 instance is in auto scaling group increases by set amount of weekend days. Which type of scaling is the most appropriate in this case? So the option for this one is schedule. When you can predict the bump, even weekend, same amount, schedule scaling is the cleanest solution. You can tell the group when and how much to scale, and it would adjust its timetable accordingly. Now let's see the other options. We are not going for manual, because that's you clicking buttons. It works, but it's an error prone and not more appropriate for recurring things and predictable patterns. Then we are not selecting the dynamic also, since dynamic policy set target and tracing response to metrics in real time. You don't need that complexity for fixed known increase. And we are not going for predictive as well, because forecasting is for pattern learned from history. Here you already know the exact weekend change. Question number three says that a DevOps engineer launches a fleet of Amazon EC2 instances in auto scaling group behind an application load balancer. The EC2 instance must maintain 50% average CPU utilization. Which type of scaling is appropriate to use based on the CPU utilization? Now, the target tracking scaling is the best suited answer for that one. You set the target to 50% CPU, and auto scaling automatically adds or removes the instances to hover around that value. Like a thermostat, it would adjust itself automatically. Now let's explore other options, like simple scaling is not the right option, since it's a single alarm, single action. It doesn't continuously chase a specific target, so we cannot select this one. And if we'll think of step scaling, it's not an option, because it scales in steps at thresholds, still not hold CPU at 50%. And manual scaling is not an option, since no automation is involved in that. You'd have to watch CPU and adjust it yourself. Question number four says that how can a user vertically scale an Amazon RDS database? So you can scale an RDS database by changing the instance class or size. Vertical scaling means to scale up or down the box. In RDS means that moving from say DB-T3 medium to DB-R6G2 extra large. Now let's explore the other options, like by adding read replicas is not an option since that's horizontal read scaling, not vertical. We cannot select the second one for sharding the database. It means that an application level horizontal partitioning, not vertical, and we cannot go for the creating dedicated read and write nodes because that's an architectural split, not a bigger single instance. Question number 5 says, how can AWS customer horizontally scale an Amazon Aurora database? It can be done by adding Aurora replica instance by using Aurora auto scaling. Aurora replica adds read capability for horizontal scaling, and Aurora can auto add or remove them based on the load. Now let's see the other options, like creating a cloud watch alarm. That's not the option since alarms are themselves don't scale Aurora. They are just signals, and we are not selecting by changing the instance type since that's vertical scaling, and we are not creating a scaling policy since policies need a mechanism. For Aurora, replicas are the mechanism. Question number 6 says that how does Amazon DynamoDB performs automatic scaling? That is done by it adjusts the provisioned throughput capacity in response to traffic patterns. Application auto scaling tunes your table index, read and write capacities, or switches you to on-demand behavior, so you don't have to hard code the throughput. It changes the instance type in response to changes in processing load. That's also not possible since no instances to resize in DynamoDB. Question number 7 says a fleet of Amazon EC2 instances is launched in an Amazon EC2 auto scaling group. The instances run an application that uses a custom protocol, which is TCP port 42000. Connections from the client systems on the internet must balance across the instances. Which load balancing solution is the best solution? So network load balancer is the right solution since network load balancers operate at layer 4 and is built for TCP, UDP and TLS, including custom protocols and ports with very high performance and static IP support. Now let's go through the classic load balancer. We are not selecting this one since classic load balancers are the legacy systems and limited. ALB and NLB are the modern choices. So we are not going for gateway load balancers since for inserting third-party network appliances, not app traffic balancing, and then application load balancer is also not the right option since it's layer 7, which is HTTP HTTPS, not suited for an arbitrary TCP protocol. Question number 8 says that a company must build a highly available website that uses server-side scripting to serve dynamic HTML. Which solution provides the highest availability for the least cost and complexity? So the answer for that one is an auto scaling group launches the EC2 instance, which are served by an application load balancer. DNS name resolution points to the load balancer. This is a standard in a high availability web tier. Stateless EC2 behind a load balancer, it would be spreaded across availability zones with route 53 pointing to one managed endpoint, simple and cost effective for server-side HTML. Now we are not selecting the first one since it says that it's an auto scaling group launches EC2 instance which is served by the network load balancer. Amazon Route 53 uses latency based routing. That's wrong because network load balancer is for layer 4. You lose the load balancing HTTP feature, and then latency based routing across regions add complexity to the cost. Now we are not selecting the second option also because it deploys the second web server in another region. Amazon Route 53 uses failover routing for disaster recovery because cross-region disaster recovery raises complexity and operational overhead, and Amazon S3 hosts The website DNS name resolution points to S3 bucket. It's great for static websites, but this app uses server-side scripting, which is S3, and it can't run. Question number 9 says that a user in location A connect to an application in region A. Users in location B connect to the same application in region B. If the application in region B becomes unhealthy, traffic from A must be redirected to application in region B. Which solution meets the requirements? So we can go for use geolocation routing with failover record in Amazon Route 53. The reason is that geolocation sends each geography to its home region. Pair that with failover healthy checks so that if region A is down, location A traffic would automatically flip to region B. Now, if we look at the first option, which says use geoproximity routing and network load balancer that is attached to both regions, it's wrong because geoproximity biases by distance, weights, not hard by A region to region A, and then network load balancer can't span across regions. Now, the other option over here was to use a load balancer with Amazon CloudWatch alarm. That's not also right, where the load balancing is regional. It won't route users between regions by itself. And the last option, which was about latency based routing in Amazon Route 53 with Amazon CloudWatch alarms. Latency routing picks the lowest latency region, not sends A to region A unless it's healthy. And the last question says that a software engineer has created an AWS account for their own personal development and testing. They want the account to stay within the AWS free tier and to not generate unexpected costs. Which approach will work and will require the least effort? So the right answer for this one is to create an Amazon CloudWatch alarm to send an email message when the account billing exceeds $0. Enable the billing metric in the CloudWatch, set an estimated charge alarm, and you'll get an alert the moment anything billable shows up, simply, fast, and would be there with a very low effort. Now we are not going for the second option with create Amazon CloudWatch metric to monitor the account billing and limit it to $0. The reason for that is you can monitor, but you can't enforce a spend cap in AWS. And then the second option, create a service control SCP to restrict all services that are not included in AWS free tier. That's also not right because free tier eligibility depends on the usage and time, and SCP can't universally block non-free tier usage. And then we cannot select sign in to the AWS management console each month and check the billing standard, since it's a manual process and manually checking are late and error prone, so you might miss mid-month charges. So that was our module number 10, which talks about implementing, monitoring elasticity and high availability.